This is the last lesson of the day. Formulas and solving them and working with them, using inverse operations, all kind of coming together today to be able to do this. So let's talk about this formula, y equals mx plus b. Now you guys know it for lines, but let's just forget that for a second. Let's just say I want to solve for x. Okay, let's say I want the x by itself. Okay, if I want the x by itself, I got to get rid of two things. I got to get rid of the m and the b. And I want the x by itself. So if I wanted to solve for x, I would first get rid of the plus b using inverse operations. What is the opposite of adding b? Subtracting b. B's will cancel out, and whatever you do to one side of the equation, you do to the other. You'll be left with this. Y minus b equals mx. All right? Next, the m. Now that m is multiplying. So the opposite of multiplying is to divide. Now, if you divide one side, you divide both sides, but actually you divide everything. So the entire left side gets divided by m. So to write my answer here, I would just write it like this. Y minus b all over m. And that is the answer for x. So you can manipulate formulas and rewrite them by using inverse operations. Okay, let's just say there was a word problem. So let's say you spent 50 bucks. You spent $50 to make a poster, right? Now, the poster paper cost you 30. So the paper was $30. To print, they charged you, I don't know, 50 cents a word. So it was 50 cents per word. Okay, so how could you use this equation with this scenario, right? So, well, $50 is what you paid. That would be your total. That would be your y, 50. Okay, now you started with the paper, which was 30 bucks. That would be your starting point. That would be your initial value of 30. Okay, and then they were charging you 50 cents per word, so it'd be 0.50 per word. Actually, x. We'll make x our words. When you combine this, you would get 50. All right, so how would you solve this? Well, if you move things around, like if you move the 30, you get 20, right? And then if you divide the 50 by both sides, you would actually get 40. Well, what does the 40 represent here? Well, 40 isn't money. 40 is x. And x in this case represented the words. So the sign or the poster had 40 words, and that's why it cost you 50 bucks. Okay, so you can use the formulas to help you solve word problems, but whenever you look for the information, you have to know where to plug it in. So that was y, this was b, this was m. Okay, so when you read a word problem, just identify what numbers they're giving you and where you can plug them into the formula, and then you can do what you did here, inverse operations to solve, which is how I got this answer. Okay? All right, so here's another formula. This is called the distance formula. Okay? Now the distance formula is pretty straightforward. So you have distance equals the rate of speed, or the rate of change, multiplied by time. Now, it doesn't always have to be speed. It can be how fast something is growing, how fast something is moving, how fast someone is doing something, just the rate of growth or the rate of change, okay? So let's just say there's a word problem. A car is traveling 50 miles per hour. So 50 miles per hour would be identified as the rate, and they are going to drive 200 miles. 200 miles would not be time, this would be distance. So what you would do is you would take these numbers, right? 200 goes for distance, 50 goes for r. Now you don't know t, so your job is to solve for t. Well, how do you solve for t? Inverse operations. Get rid of the 50, inverse operations, dividing by 50. And then you would get t equals 4. And t represents time. And in this case, miles per hours. This is 4 hours. So when it comes to word problems, you also want to know what you're measuring, what you're talking about when you're using these problems. All right? Next. Okay, shapes. So you guys know to find the area of a rectangle, you have to multiply the length times the width, right? But let's say it's a 3D shape. Well, if it's a 3D shape, you can also incorporate a third dimension, which is, let's just say, the height. And now you find something called volume, which is how much fits inside, okay? So let's just say you have the length and width of a shape is 4 and 5, okay? And you don't know how the height is, but let's say you know that the volume is 80. Let's just say it's 80. So how much fits inside is 80. So we'll go volume is 80, the length is 4, the width is 5, and you're looking for h. Well, what you want to do is simplify this, combine that, then solve for h by getting rid of the 20. What's the opposite of multiplying by 20? Dividing by 20. And you would get the height as 4. Okay? Now, another way you could have done it is to rewrite the formula. So let's say you want the h by itself. Well, how do you get rid of length and width? Well, these numbers are multiplying. So if you divided length times width, they would both cancel out. You could put them over here. And now height equals the volume length times width. And now let's look at this formula again. The volume is 20. Length and width are 4 times 5. I'm sorry, the volume was 80. 4 times 5 will give us the height. Well, 4 times 5 is 20. 80 divided by 20 is 4. So you get the same answer, okay? So just different ways of going about it. Rewriting the formulas or just plugging in and solving, okay? Kind of the last one I want to show you here is for temperature. So this is the formula for Fahrenheit using Celsius. So let's just say, for example, let's say it's 20 degrees. No, let's go a little bit bigger. Let's say it's 40 degrees Celsius. So if it's 40 degrees Celsius, you would take the 40 and plug it in for C. And by plugging it in, you would get the answer for F, for Fahrenheit. So in this case, there's a couple things you could do. You can multiply 9 times 40 and then 5 times 1. But there's something called cross-canceling, which means when I look at this, 40 can be divided by 5. And if I divide it by 5, I would get, instead of 40, I would get 8. I would get 8 here, because 40 divided by 5 is 8. And that would actually help me solve this a little bit faster. So you have 1 times 1 is 1, 9 times 8, that is 72, plus 32. Now you can put it over 1, but I'm not going to, because if it's over 1, it really doesn't matter. So then, after I've simplified that whole thing, I just add 32. F equals 104 degrees Fahrenheit. So if you ever see something as 40 degrees Celsius, that means it's 104 degrees Fahrenheit. And that's how the formula works. Okay, and this formula can also be manipulated. If I wanted to solve for C, right? If I wanted to solve for C, the first thing I would do for this formula, I wouldn't move the fraction first. I would wait on the fraction. The first thing I would do is move 32. So inverse operations, subtract 32 from both sides. I would start like this. Then I'd move the fraction using like the reciprocal. So the reciprocal for 9/5 would be the opposite fraction, 5/9, right? That'll cancel it out, and whatever you do one side, you do the other. Okay, and so you would have 5/9 times Fahrenheit minus 32. Yes, actually I would leave it like this because I wouldn't want to distribute the fraction. But this would be a formula to solve for Celsius. In this formula, I would plug in my degrees in Fahrenheit, subtract, multiply, and it'll give me the temperature in Celsius. And guys, that's just some examples of formulas. Now there's a lot of different formulas, and you basically are using inverse operations and plugging in numbers to solve for them. And that's it.